I'm going to turn a slider into an instrument. The way I'm going to do that is using a K slider, or actually using a MIDI keyboard. What I want to do is that when I hit a note on the MIDI keyboard, I want that to set a pitch for a sample. And then when I slide the slider to the right, I want the sample to play at that pitch. Then if I hit another note on my MIDI keyboard, I want that to set the pitch for the sample at the left-hand side of the slider, and so on. If I hit another note, I want that to be the pitch when the slider slides to the right. This will allow me to kind of play a sample like an instrument, reversing it and swapping direction of play, and it might be quite fun. First things first, we're going to need a buffer. We'll call it slider. And I'm going to use a groove object to actually play the sample. The most important thing is going to be changing the speed, and so I'll just set up a receive. To be able to send a floating point number to be able to control the speed of this groove object. Let's give it the at loop 1 attribute to mean that looping is on. We'll use a replace message to load a sample into our buffer when the time comes. Now to be able to kind of control the pitch of a sample, we need to divide the frequency of a MIDI note. So if we connect a MIDI to frequency object to a K slider and hit middle C, it gives us a number. Actually, let's put that into a message box. So that is the frequency of middle C. If we select that number and put that into a divide box, then when we hit middle C, the result will be 1. If we hit an octave up, the result will be 2. If we hit an octave down, the result will be 0.5. And so basically, by playing a sample at that speed, it will, the relative pitch of the sample will be able to be controlled by either a K slider object or a MIDI keyboard. So I want the left hand side of the slider to play notes in reverse, or to play samples in reverse, and the right hand side to play them forwards. So we're going to need a little system for sending, if we use a G switch 2, we're going to need a little system for sending notes to kind of either to the positive side or to the negative side, the reversed side. We can use a trigger to trigger with the arguments float bang. I mean, first a bang is sent out. We can use that bang to toggle the toggle, which is controlling which of these two outlets the number is going to come out of, and then to send the number. And so that should mean that that when we hit numbers on the K slider, they kind of alternate between those two number boxes. Now we just need to make one of these negative. If we exclamation mark minus followed by an argument means that it will be 0 minus this number will be the sum. And so we should now find that we're getting negative numbers out of the left hand side, positive numbers out of the right hand side of this switch. That's what we want. Okay, so how on earth do we translate that into the values that is being output by a slider? The messages that are relevant for us here are, what are they? Min. So min $1 will control the left hand side of the slider. It sets the minimum value. So if we set the minimum value to 3, we need to make this slider into a floating point one. If we set the minimum to 3.1, then the left hand side of the slider will be 3.1. If we were to set it to minus 100, then it would be minus 100. But the right hand side of the slider would be determined by the range, or the messages, the size. And so if we want the left hand side of the slider to be playing our reverse notes, so the left hand side of this setup, then we're always going to want the left hand side of the slider, the minimum value, to be whatever last came out of the left hand side of this switch, the negative number that came out of the left. But we can't just plug the right hand number into the size argument, because well, we can see what happens if we do. So if I hit a C below middle C, which is sent a minus 0.5 out of the left hand side of this setup, that nicely sets our slider object to output a minus 0.5 on the right, on the left, sorry. If I was to then hit middle C, which sends a value of 1, which would play our sample at normal speed, and then slide to the right, we're not getting the value of 1 that we want, because the slider is, all we're doing there is setting the range. What we need is, we need that value of 1 plus the previous 0.5 to mean that, to make the right hand side of the slider equivalent to a 1. So how can we do that? We can use this and a box with an F. It's a floating point box. It can store a floating point value, and so that now we don't want the minus, we don't want it negative, we want it positive. So we want to store the number that comes out of the left hand side of this G switch ready for the next positive number. Then when a positive number comes out of the right hand side, we want to trigger an addition operation. And so we'll use a trigger to do that. The arguments FB mean that first a bang is sent out. So first we want to bang out the floating point that was stored last time. We want to use that as the argument for this addition operation, and then send out the floating point number that we've just received. And so that should mean that when I do the same thing again, let's connect that up. So if I hit the C below middle C, I get minus 0.5 out of the left. The left hand side of our slider is indeed at minus 0.5. If I now hit middle C, then we've set the size of the slider to 1.5, but that means, because the left is at minus 1.5, means the right hand side will be 1. So that's looking good. just try that out with a few more notes. So I've just hit a B flat. That has put this negative number out on the left, and that is indeed the left hand side of our slider. If I was to then go one semitone down to 0.841, the right hand side of the slider is set at that. So that's fab. Now what we can do is send that to over to the signal that's controlling the speed of our groove. Because this is something that I want to be able to actually play, I don't really want to use the K slider. I want to use MIDI input. To get MIDI data into a patch, you can use the MIDI in object. Once you've created it, if you then double click, you should get a list of the MIDI inputs that Max is recognizing on your system. After MIDI in, you need a MIDI pass. I think that's because MIDI in just sends out loads of information and you don't need all of it. So MIDI pass breaks up the zillions of MIDI messages into chunks, and then we can work out what we actually want. We want note-ons and note-offs. So I'm not sure that we want the note-offs here, so I'm going to use an object called strip note. And what strip note does is to filter out note-off messages. We might just want to quickly add a bit more control over the sample that we load into the groove object, and we can use a waveform object to get more control. If we load a waveform, we can use the @buffer_name attribute in order to associate it from the start with the buffer slider, and basically the waveform object, out of some of the outlets at the bottom, will send the time of selections, the time of a loop that you can select on the image of the waveform. In fact, if you open up the waveform's help file, there's a really helpful little setup already made here. So in fact, let's forget about the one that we've already got and just paste the version from the help file in. And what we can do is, this version is quite busy, there's quite a lot going on, but we can see that the outlet which has to do with the selection start is going into the second inlet of the groove object, which sets the loop minimum. And so what we can do is we can set up a send object and call it min, and then just drag that cable into our send. Do exactly the same with another send object. We'll call that one max. We can turn those into receives and pop them into our groove object over here. Just as a reminder, I'm using these #0 prefixes to the names, just in case this ever gets turned into an abstraction or a B-patcher. They will allow multiple instances of this patch to run in B-patches if ever I turn it into a B-patcher. So we're sending the minimum and the maximum loop times from this waveform object, and we can now just get rid of all of this busyness. We can send a message set slider to associate this waveform object with the buffer called slider. And this waveform from the help file has got this handy little B patcher to the left of it, which allows you to choose different selection methods, and to use the mouse to kind of well, just tinker around with them and see what they do. So this will allow us to, if we've got like a file loaded into our buffer. Oh, and by the way, you can see that while the video was paused a second ago, I loaded a file up into the buffer using the replace message. And so now what I'm able to do is to, instead of having a kind of having to just play the whole thing, I can kind of zoom in on a little passage and find smaller loops, smaller sections to send through this system and see if it makes a nice sound. There's actually a couple more things that we might want to do before we play around with this. Because this is sending loops, we've set this up so it's sending loops through Groove. If you're not careful, if you don't think about it, then the point at which the loop loops can end up clicking, because it can kind of result in a kind of an immediate transition between sample values. There are a number of ways that we can potentially try and remedy that. One is within the waveform object. If we get its attributes up, then one of its attributes is, where is it? I can't find it in that list. Let's have a look in the inspector. There it is, down at the bottom, the snap mode. So the snap mode by default is on nothing, but if you set it to 0 crossing, then basically when you make a selection, the waveform object will try and make that selection at a point where the waveform is crossing 0. And what that means is that when it loops from the end of the loop to the start of the loop, hopefully it will be going from 0 to 0, meaning that it will not result in a click. Another way that we can deal with clicks is using the sync output from the Groove object. And so what the sync output does is that as a loop loops, this just sends out a signal that goes between 0 and 1, basically a phasor. And we can use that phasor to control a window. So windowing is when you basically kind of ramp up the volume at the start of a loop and then ramp down at the end, just in order to kind of dip the volume at that point where the loop is looping around. So if there is a click or if there's a sudden transition between values, you're kind of basically dipping the volume very quickly. We can use trapezoid to achieve a window. There's different ways of doing it, but basically the trapezoid object, if you send in a phasor going between 0 and 1, then it will, depending on the arguments, it's got up and down arguments, it'll basically send out a signal that kind of ramps up and then ramps down at the beginning and end of that that movement from 0 to 1. So I guess we might want to be able to kind of control it. Let's take the one from the help file. And so basically if we take the phaser that's coming out of the sync output of the groove object and then multiply it by the trapezoid, so send that phaser into the trapezoid, which will then create our window, our windowing envelope. And so now if we multiply our signal by that envelope, then this will be another way in which we can deal with any kind of unwanted clicks that the looping is causing. Okay, I think I'm now ready to have a little tinker with this. One final change that I've realised I need to make is that this slider object, when the notes coming in are quite low, I think the slider rounds up in some way, and so it gets inaccurate if you're using it on lower notes. And we can fix that by just making the slider bigger. So we can just multiply by, I'm going to multiply by 10,000, which seems pretty safe. And then, so the numbers coming out of the slider are way bigger than we want them to be. So we can divide by 10,000 as well. Maybe I need to make sure that these are floating point numbers. I'm not actually sure if I do, but just in case. That should sort out the inaccuracies that were being caused by the slider rounding things up.